So we looked at the absolute value graph in our basic function graphs, but let's just do a quick review and talk about how to graph it using transformations. Okay. So remember that the absolute value graph takes all positives and leaves them positive, and takes all negatives and turns them positive. So what does that end up looking like on a graph? Well, let's do a quick sketch so that we can remember. Okay. When I plug in 0 to the absolute value graph, I get 0. So I have the point 0, 0. When I plug in 1 for x, the absolute value of 1 is 1, so I have the point 1, 1. When I plug in 2, the absolute value of 2 is 2. When I plug in 3, the absolute value of 3 is 3. So this side of my graph just looks like a straight line. Similarly, on the other side, when I plug in -1, the absolute value of -1 is 1. When I plug in -2, the absolute value of -2 is 2. The absolute value of -3 is 3. So I get a straight line going the other direction. The graph of the absolute value is this nice V function. Now, like with any other graph, we can flip this upside down. So remember, a negative out in front would flip this upside down. That's an x-axis reflection. Okay. Now, technically, we can also put a negative inside. A negative inside with the x is a y-axis reflection. But in this case, a negative inside with the x wouldn't do anything because this is symmetric about the y-axis. If I want to move this up and down, I'm going to add or subtract outside of the absolute value. So absolute value of x plus 2 would pick this graph up and move it up 2. If I did absolute value of x minus 2, it would pick this graph up and move it down 2. Okay. If I want to move this left and right, remember that left and right, or horizontal shifts, happen inside with the x. So if I did say x minus 2 inside the absolute value, that minus 2 is going to shift our graph 2 to the right. Okay. If I did absolute value of x plus 2, that would shift our graph 2 to the left. Okay. And last, we can think about horizontal and vertical stretches. So if I have that absolute value, and I put a 3 out in front, that 3 is going to stretch our graph. So it's like I picked up this graph and vertically stretched it. That essentially makes it kind of taller and skinnier. If I have a number that's less than 1, say 2/3, that's less than 1, that would squish this graph down sort of 2/3 its original height vertically. Okay. We can also think about horizontal transformations. Those are multipliers inside with our x, so 3 times x, or 1/3 times x. And those act similarly to horizontally squish or stretch our graph. Okay? All right, let's try to put all of this together and sketch a graph of f of x equals -3/4 times x minus 2 plus 7. Okay? So remember, the basic shape of our graph is that absolute value graph, kind of centered at 0, 0. And what we want to do is we want to figure out what transformations we've applied to this graph. So this negative out in front, that's an x-axis reflection. So that's going to flip our graph upside down. Okay? This 3/4 is less than 1. So this is going to act as a vertical compression, meaning we're going to squish our graph down. This minus 2 inside with the x is a horizontal shift. That's going to go right 2. And this plus 7 is a vertical shift. That's going to go up 7. Okay? So if we put all of that together, here's our Cartesian coordinate system. 1, 2, 3, 4, 5, 8. All right, so we're going to try and put all of that together. So I started here at 0, 0. Okay, I know that I flipped upside down and I vertically stretched. I've also moved to the right 2 and up 7. 1, 2, 6, 7. So here's kind of my new starting point for my graph. I'm going to open upside down, and I'm going to be kind of skinnier than I was before. Okay, so there's a sketch of this graph. In general, sketching absolute value graphs is not too terrible as long as we can identify our reflections, horizontal and vertical shifts, and vertical stretches or compressions.